love me. Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.
The information provided in this article is my own personal opinion and research. You may share your opinion in the comment section at the end of this article.
Code optimization.
What is code optimization? Code optimization is any method of code modification to improve code quality and efficiency. A program may be optimized so that it becomes a smaller size, consumes less memory, executes more rapidly, or performs fewer input-output operations. The basic requirements optimization methods should comply with is that an optimized program must have the same output and side effects as its non-optimized version. This requirement, however, may be ignored in the case that the benefit from optimization is estimated to be more important than probable consequences of a change in the program behavior. Why we need code optimization: clean our code base, higher consistency, faster sites, better code readability, more efficient refactoring, more straightforward debugging, improved workflow, easier code maintenance, quicker feature development, smaller technical debt. Levels of optimization. Optimization can occur at a number of levels. Design level. At the highest level, the design may be optimized to make best use of the available resources. The implementation of this design will benefit from the use of suitable efficient algorithms, and the implementation of these algorithms will benefit from writing good quality code. The architectural design of a system overwhelmingly affects its performance. The choice of algorithm affects efficiency more than any other item of the design. Compile level. Use of an optimizing compiler tends to ensure that the executable program is optimized at least as much as the compiler can predict. Assembly level. At the lowest level, writing code using an assembly language designed for a particular hardware platform will normally produce the most efficient code, since the programmer can take advantage of the full repertoire of machine instructions. The operating systems of most machines has been traditionally written in assembler code for this reason. Runtime. Just-in-time compiler and assembler programmers are able to perform runtime optimization. When to optimize. Optimization is often performed at the end of the development stage, since it reduces readability, adds code that is used to improve the performance. Criteria for optimization. An optimization must preserve the meaning of a program. Cannot change the output produced for any input. Cannot introduce an error. Optimization should, on average, speed up programs. Transformation should be worth the effort. Improvements can be made at various phases. Source code. Algorithms transformations can produce spectacular improvements. Profiling can be helpful to focus a programmer's attention on important code. Intermediate code. Compiler can improve loops, procedure calls and address calculations. Typically only optimizing compilers include this phase. Target code. Compilers can use registers efficiently. People transformation can be applied. Types of code optimization. Common sub-expression removal, dead code optimization, loop optimization, common sub-expression elimination. Common sub-expression elimination is an optimization that searches for instances of identical expressions, that is, they all evaluate the same value, and analyzes whether it is worthwhile replacing with a single variable holding the computed value. Dead code optimization. Dead code elimination is a compiler optimization that removes code that does not affect a program. Removing such code has two benefits: it shrinks program size, an important consideration in some contexts. It lets the running program avoid executing irrelevant operations, which reduces its running time. Dead code elimination is of two types. Unreachable code. Redundant statement. Unreachable code. In computer programming, unreachable code or dead code is code that exists in the source code of a program but can never be executed. Redundant code. Redundant code is code that is executed but has no effect on the output from a program. Loop optimization. Loop optimization plays an important role in improving the performance of the source code by reducing overheads associated with executing loops. Loop optimization can be done by removing loop invariant induction variables. An example of loop invariant. An example of induction variables. Good and bad outcomes of optimization. In programming, almost everything should be treated from the viewpoint of rationality. Optimization is no exception. There is a belief that code written by an inexperienced assembler programmer is 3-5 times slower than code generated by the compiler. Zubkov. Widely known is a phrase by Knuth regarding early low-level optimizations, such as attempts to save on operators or variables. Premature optimization is the root of all evil. However, one should understand that multiple complex optimizations at the level of machine code may cause a great slowdown of compilation. The benefit they allow you to gain may be much too insignificant when compared to general system design optimizations. VERF. One should also keep in mind that modern languages, with all their syntactic and semantic frills, have many nuances and subtleties, so that a programmer who isn't familiar with them may be surprised by an outcome of optimization. For example, take C++ and the so-called return value optimization, when the compiler avoids copying a temporary object returned by a function. Because the compiler omits copying, this method is also called copy elision. So, the following code